Example 3, use a graphing calculator to solve the equation. And then it says solving exponential equations by specifically graphing. Letter A, 3.1 to the x plus 2 equals 9.61. Now, if we were trying to get these bases the same, we have a 3.1 and we have a 9.61, that's not pretty. I honestly don't want to do that, so we're definitely going to use a graphing calculator. Now, when you're using a graphing calculator, you're going to look at both sides of the equation. First, you're going to have this side of the equation. Make a mental note, write that down. And then you're going to have this side of the equation. Make sure you have that because we're going to graph both separately. So let's go grab your calculator. I'm going to come back up here to Math Tools. We're going to get the graphing calculator. And then the first thing we're going to graph is that left side of the equation. So on that, we had 3.1 to the power of x plus 2. And then there's the graph, and that is an exponential function, and it looks something like that. Now, second one, so graph number 2 down here, and we're just going to put 9.61. Okay, now when I graph that, notice I don't see anything, and the reason is because this is at 9.61, and my graph only comes up here to like 6 or 7. So we're just going to drag it a little bit until I see 9.61, which I don't, so maybe I need y equals in here. There you go. You need y equals 9.61 because it's just a whole number. And then really what you're looking for is you're saying, okay, well, when does this function equal this function? Well, they're equal to each other when they hit. Well, they hit right here, so I'm going to click it until it stays. And keep in mind, if you're solving, you're looking for what x is. So here you have x and you have y, and really you just want what x is. So 1.794, x equals 1.794. All done. Letter B. So 4 to the power of x minus 3 equals 3x minus 8. Again, this has a base of 4, and over here you're actually dealing with two things. This wouldn't even be nice to try to like figure out a base, so we're just going to graph it. Here we have the left side of the equation. Here we have the right side of the equation, and we're going to graph them both separately. Go back to your calculator. I'm just going to delete these. In the first one, I'm going to put 4 to the power of x minus 3. In the second one, I'm going to put 3x minus 8. And then here, I'm looking, this one is my exponential. It's kind of curving up. This one is actually a line. So I'm looking, and I don't see anything. Like, you know, this one's just kind of like keep going like this. It's going like that. Are these ever going to touch? And to me, it doesn't look like it. It looks like they might have touched in here somewhere, but they don't. Which means what, people? This is a no solution. Because graphically, they never touch. Letter C, same idea. We're going to graph the left. We're going to graph the right. And we're going to see what happens. The left equation, I'm going to put a parenthesis, 1 divided by 4, and then I'm going to close my parenthesis to the power of x. And then my second one, negative 2x minus 3. So if I'm looking at that, wow, once again, okay, these never intersect. Looks like they would have got close right in the middle here, but no intersection again. So back over, once again, no solution. Now, do you think it would be possible, graphing something like this, to have more? Well, I mean, we've got no solution. We could get one solution, but do you think it would be possible to have more than one solution? And I'm thinking, let's just play a game here. What if I change this to a plus? Now how many solutions do we have? And you actually have 2, okay, because it hits once here and it hits once here. So be careful when you're doing these. If you're graphing, you can have no solution if they don't touch. You can have one solution if they touch once, or you could have two solutions if they hit twice. And the solutions here would have been negative 1.222 and 1.431. So just be aware of that.